Hello, my name is Levi Lovell and I'd like to introduce my final project for GIS 510. The problem that I want to introduce and solve pertains to tornadoes in North Carolina. We all know that tornadoes can have significant impacts to both life and property. Analyzing historical tornado events is a necessary step in preparing for future events. Since NC State is in North Carolina, and more specifically Raleigh, this will be the general focus area for the project. I will be discussing the economic impacts of a particular tornado that struck Raleigh on April 2011, as well as tornado frequency for North Carolina as a whole, to determine the most suitable locations for storm shelters. Particularly in areas with substantial numbers of mobile homes, storm shelters are viable options that have the potential to save lives. Historical tornado frequency, tornado strength, and mobile home percentages will be used as variables to determine the suitable shelter locations. Both Storm Prediction Center data and Wake County GIS data will be used in this analysis. Now you can see the project description, which reiterates some of the points I just made about the expected outcomes of the project. The analysis questions I seek to answer are listed below, the first of which I will answer using a web map. The question states, given tornado data and parcel information, what is the estimated cost of damages to buildings within the tornado path length and width of the EF3 tornado that struck Raleigh in 2011? The answer may seem surprising, and it is. $2.78 billion is actually a gross overestimate of the actual damages as a result of the tornado. I will now show you how I arrived at the answer and why it is an overestimate. First, I will show the web map. The layers of interest to answer the first question are the tornadoes from 1975 to 2015, as seen here, parcels for Raleigh in green, as seen here, the tornado path for Raleigh in pink, as seen here, and the parcels in the tornado path in brown. As stated, the tornado of interest is the April 16th tornado that struck Raleigh. Now, just focusing on the path length and width through the Raleigh city limits, as well as the parcel information within the tornado path, it is evident there are many parcels and thus buildings impacted by the tornado. As you can see here, each of these are individual parcels. The error obtained in the damage estimates results because the building value information available is for the entire parcels. However, only parts of the larger parcels were impacted by the tornado, as seen here. This is why the damage estimate of $2.78 billion is an overestimate. These shapefiles were created in ArcMap and imported into the ArcGIS online web map. The parcels in the tornado path layer were derived from the parcels in Raleigh, as well as the buffered tornado path. Now we will look at the ArcMap version. As you can see, the layout is very similar to the web map. Here are the Raleigh city limits and the tornado path and width layers. This shows all the parcels in Raleigh as well as the intersected layer showing parcels within the tornado path. By opening the attribute table of the parcels in the tornado path and summating the building values, you can see the value of $2.78 billion here. There are clear examples, as I said, where the parcels extend beyond the tornado width, as seen here. And you will notice that the colors are different for those inside the tornado path. And this is because in ArcMap, I was able to categorize the parcels by building value. So you can see these parcels here have a greater value than some of these parcels here in yellow. Now we will revisit the other two questions and discuss expected outcomes. The expected outcomes to the second question is that locations that have experienced frequent tornadoes and have high percentages of mobile homes are likely candidates for storm shelters. Such areas could include, as you will see in the web map, these areas could include near Lumberton or Pembroke, near Concord, and near Snow Hill. The expected outcome to the final question is simply that the storm shelter that is located within 5 miles of a significant population center would be the storm shelter that would be the largest. Since these areas have greater populations, these would be prime candidates for the largest storm shelter. These will be determined using a series of geoprocessing tools, including buffer, clip, intersect, dissolve, and statistical analysis. This concludes the analysis for the first part of the final project.